So, picking up where petroleum left off, we have natural gas. So, this means substances that at standard temperature and pressure are in the gaseous form. And for the most part, we're talking about methane, remember CH4, and other gases like butane, which you would find in a lighter, propane, which we use for cooking and heating, and gas grills and things like that. Um, these are found in nature underground. And then, usually, in order to transport it, because gas takes up a lot of volume, we cool it down and exert pressure to liquefy that. So it's a lot easier to move it, it doesn't take as much space. Other places where we find natural gas as opposed to in association with petroleum, we do find it in association with coal. And we can find methane trapped in places like under the permafrost and deep ocean sediments. And those are some things that we're going to have to start to paying better attention to when it comes to things like climate change melting permafrost, and also as a potential source of methane moving forward. We can find a more renewable source of methane when we look to feedlots and wastewater treatment plants. So the natural gas is produced by the decomposition of organic material, both of which happen to large extents here, but then also within landfills because people are throwing away organic materials like food scraps. And so we'll talk about natural gas again when we're talking about more renewable substances. So just as a quick reminder, a lot of the natural gas that's formed is in association with petroleum because of the plankton that accumulate along the ocean sediments, and then without undergoing decomposition, we have the sort of compression and modification of those carbon-based organisms into natural gas, petroleum, etc. And the other thing to be aware of is that that can happen where you have a lack of decomposition. So in colder regions, you can end up with methane building up, or you can trap that without necessarily the formation of petroleum. It doesn't need to be quite as long-term production as petroleum needs. And finally, we do have methane that comes from abiotic sources, excuse me. So they can come up actually through rock and tectonic activity. So we do have methane that comes in through the Earth's processes as well as the non-decomposition. So where do we get lots of methane and natural gas? Well, first of all, I wanted to point out the fact that we use the volumetric cubic feet or cubic centimeters, cubic meters when we're talking about gas, because it takes up a lot of volume. And in this situation, to be able to compare reasonably, we're talking about trillions of cubic feet. We see that North America, US and Canada produce a lot. Russia and other former Soviet Union nations produce quite a bit. Middle East, it shouldn't really be a surprise. We're seeing a lot of overlap from places where there was a lot of petroleum and coal. And if you want to put that to more specific countries, we've got places like Russia, the US, Canada, all the Middle Eastern countries, Australia. We saw some of these other countries before. Again, coal gives off natural gas, petroleum associated with natural gas as well. So if we take a look in the United States, it should not surprise you to see this. Here we have lots of overlap with petroleum, with coal production, and then we also have those offshore reserves that are so famous in the Gulf of Mexico, off the coast of California. There's quite a bit of natural gas that is available. And so we use natural gas for electricity production, for heating, for cooking, etc. Part of the reason for that is that with the high pressure that gas exerts, it's fairly easy to get it out of the ground when it's in large volume, and therefore and you don't really have to do much refining or separating from pollutants, so you end up with a very high amount of energy output and very little energy input. So a lot of high net energy. It's fairly easy to transport. It also is good because you don't have as much land use when you're extracting it. And we have a couple of different ways of getting the energy out of it, such as fuel cells, which allow you to separate it without combustion. And so you can have electricity production from more of a redox reaction. And so you don't necessarily have to have the carbon dioxide and oxygen and the waste heat associated with it, although you do have the carbon dioxide and oxygen, water, excuse me. However, the kinds of natural gas we're talking about, that's a non-renewable resource, and methane, remember, that is a major greenhouse gas, and in fact, it per molecule of methane is much more effective at trapping infrared wavelengths, plural, of light, and so it's sometimes referred to as being in the 23 to 25 times more potent, meaning it absorbs more of the infrared and therefore is more effective as a greenhouse gas. The other thing to note is that in order to transport it in a feasible way, you need to condense it into liquefied natural gas. That takes a lot of pressure, and while you cool it down quite a bit, that high pressure means that liquefied natural gas is pretty explosive. So you have to be very careful, and there's the potential for harm. And then this does require pipelines, which is a habitat destruction concern. Finally, the other big problem that we talk about when discussing natural gas is the more modern way of extracting natural gas from areas that were not so economically feasible before, and also were harder technologically. So just like oil sands and oil shale, it is now economically feasible to try to extract and successfully extract the natural gas that's found within the pockets of and fissures of rock. So sedimentary rock can have a lot of natural gas. So how do we get that stuff out when it's in tiny little pockets throughout an entire rock bed? Well, what we do right now is called hydraulic fracturing or fracking. Hydraulic refers to the fact that we're using a liquid under pressure to fracture or crack rock. So these are liquids that are pumped underground through a pipe to the bed, the rock formation that we know has a lot of methane in it, and that causes pressure underground, which cracks the rock, and often sand is included in that hydraulic mixture, which holds these little cracks open and allows the natural gas to escape back up the pipe and is captured by the company. However, when you're making things crack underground, it's not necessarily easy to prevent the cracking beyond where you want it to happen, and therefore you end up with methane seeping into groundwater, so the aquifers that are underground. You can also have serious problems with the fact that this liquid is, well, the substance, the mixture is not well regulated in that companies have the proprietary knowledge of what's in it. And so because the US government doesn't know exactly what's in it, it asks all of those companies to treat it like hazardous waste. And so we have a lot of this liquid being dumped in hazardous waste sites, which is sort of overflowing our ability to manage that. And we have some associated problems with earthquakes as we're pumping this liquid either during the fracturing process or in the disposal process. Sort of, people use the phrase lubricating the faults that already exists in the rock. And so we have ground slippage that happens and earthquakes that are resulting from that. So the thing about natural gas is we're moving to it more and more as we move away from coal, in part because really we're just taking methane, and the combustion process of that literally produces only CO2 and water. And so it's very, very clean when we combust it. When you compare that to all of the sulfur dioxide, the nitrous oxides, the particulate matter, all and the heavy metals that are associated with coal combustion, this is a heck of a lot cleaner. However, again, we've got that CO2, we've got the methane that leaks from the pipelines and from the extraction process, and so a lot of people are glad that we're not burning as much coal and we're converting power plants to coal, but the fact that we're still relying on this substance that we had the carbon that was captured hundreds of thousands, millions of years ago, that's now being added back to the fast carbon cycle, that's a serious problem that people would like for society to change.